Hi, so here let's see a demo of a system which I have developed for detecting smaller objects from an image. Okay, so here I have used in it use a use case of detecting wind turbines. So similar to this, detecting from aerial images, and here I'm taking actually two models, YOLO small V5 and YOLO X V5. Okay, to understand what is the performance of these models on these type of images. Okay, so further details about the data set as well as how I have approached these problems have given a very detailed information on this repository. You can just go through it once. Okay, so this is the images which are given for training. Okay, so this is the aerial image of a taken from a drone or maybe from an aircraft. Okay, so here we can see the size of the turbines is really very small. Okay, so it's detect. Let's see what is the performance of these YOLO V5 models on these set of images. And regarding the labeling and what the YOLO does inside, everything I have mentioned here. Okay, so for YOLO small, I got an MAP of 0.897. Okay, and similarly for YOLO X, I got a MAP of close to 0.992. Okay, so I'm using these two models for giving the sorry to do the prediction. Okay, so you can go through it once. So about the data set and how many epochs I have trained, all those details I've given in this repo. So now let's understand how the model is performing. Okay. So for that, I just created one UI for it to like check what is the performance. Okay. So this is the UI. So here we can choose any model, sorry, any images. Okay, so let's see this one. So I've given few options here. So YOLO small, YOLO X, and YOLO small with SAHI. So I'll be telling what is SAHI, and YOLO X with SAHI. Okay, so let's see what is the performance of YOLO small. So giving the predictions, and when I try with YOLO X, so these are the predictions from an entirely different image which I have taken, which is not similar to the training images which these models have gone through. Okay, so if I give a glance of the training images, so this is how it looks like. Okay, so normally the model will be performing well on like those sort of input data which it got trained. So if I'm giving like a image which is very similar to the training image, so like this, it will definitely give me a good result. See, the results are very good. But similarly, if I check with YOLO X as well, it will give you very good results when the input image is very similar to the trained images. Okay, but the thing is, it exhibit much poor accuracy on smaller item detection tasks with high resolution photos captured by a high-end drone and a surveillance camera. That's we have already seen. So this image, if I can show you, so this is a very comparatively a larger image. Okay, so if I give this to do the prediction, predictions are, I will say okay only, but these turbines are not getting detected. Same case goes to for YOLO X as well. So comparatively, it's a very big image, which the model doesn't trained on these type of images, but still these turbines are not getting detected. So YOLO is not performing well on smaller images. Okay, so another challenge is the smaller objects have much more diversity than a normal image, which makes the task more easy, more difficult. So if you can show one image, see this image. So these are very small images of a car taken from a drone, and the diversity of the images also will be very different if you zoom the image and if you literally look into the image. So this is another challenge for normal object detection if we apply on smaller objects. So here, to increase the performance of the model on smaller images, I have used a technique called slicing aided hyperinference, which is called as SAHI. Okay, and so what this method does is it slices the input image into overlapping smaller pixels regions, and these small slices are given to the model for making the predictions one after one, and these predictions are combined and given as a single final result. So what it tells is like, so if consider this is an entire image, so what it does is like it slices the image. See this red bounding box. So this is nothing but slices from the image. So these slices are given to the model one after one, and see here predictions will be happening on these slices of image, not on the entire image. So this is the brief idea about this technique. So this technique is currently available, which is on YOLOV5 detectron and enum detection. Okay, so let's try this in real time. So I'm choosing the same image, this one. I'm using YOLO small with SAHI. So there is one more hyperparameter which we can use in SAHI. So which is nothing but the slicing size. So it will be like so this image which we have seen. So this will be if you are selecting 64 cross 64, nothing but width and height. So it will be slicing these images into 64 cross 64, and that many slices will be input to the model, and that many predictions will be happening. I'll show you. So here I'm selecting 256 cross 256. Okay, so if I'm submit, you can see it making how many slices it is making. So you can see like it is making six number of slices of that image. Okay, so you can see what was the prediction. So I'll show you like what is the prediction in a normal case we have already seen, right? So this was the prediction. Let's see in a normal YOLO standard YOLO detection how it looks. So I'm using small without Zahi. This is the prediction. I'm duplicating it, choosing the same image. If I'm choose YOLO small with Zahi in a 256 cross 256, so this is the prediction. So you can literally see how the prediction got improved. So these many detections, these many detections it can do in a standard format, but this many detections it can do with YOLO Zahi along with 256 cross 256. But if I decrease even further into 128 cross 128, let's see how the prediction will look like. I've given the screenshot as well and different like conditions for other predictions. So you can now see like the prediction is taking a little more time because the slices are getting increased. So in 128 cross 128, I slice the images into 30 slices. So 30 predictions will be happening. So it will be taking more time. Okay, so if I show you the screenshot which I have taken from the report itself, predictions which I have given here. Okay, so this one and this one. So in this figure, this is comparatively a smaller image of size 600 cross 450. So in this, you can see at 512 cross 512 slice size. This is the prediction. If I'm increasing the slicing, if I'm decreasing the slicing like image, so the predictions are getting better and better. So you can see at 64 cross 64, it can able to do this many predictions. But the prediction time will be increased. And with YOLO X, 512 cross 512 slicing gave me this result. But when decreased the slicing size to 64 cross 64, predictions were very good. Even with the so this image is all a small size. When I'm checking with the 150,560 cross 1038, so this was the prediction. So 512 cross 512 gave me better result. 256, 128 and 64 is not that good, I will say, but 64 in YOLO small is better. Similarly for YOLO X, 512 cross 512 gave the better result comparing to the smaller slicing size. So here, so the prediction, so you can literally see the prediction time will be high if I'm increasing the like slicing time. Sorry, slice decreasing the slicing size. If I'm giving 64, it will take much more time comparing to the higher slicing size. So that is the one defect of this approach. And if the image size is small, the slicing size should keep to smaller values. And if the image size is large, keeping a slicing size higher will give you better results that we can literally see here. If the image size is very small, we need to give like a very small slicing size. And if the image size is large, we need to give slicing size which is larger. Okay, so taken some time, but the predictions are very good. Yeah, thank you.